Good evening, guys. Yes, now we are going to look at the domestic installation. So, the domestic installation, we all have the questions here and everything to help us answer. Okay, now let me do a short revision with you guys on domestic installation. My name is Mr. Mogomi PE. Okay, so now we can start. At first, what we have to know about this, we have to know how to define a domestic installation. What is domestic installation? Okay, so this installation is the complete electrical wiring system inside a home that supplies power to appliances. Yes, so domestic installation is the complete wiring system inside the home that supplies power to appliances. It can be lights, plugs, and domestic appliances like the stove, fridge, what else, the washing machines, you name them. So yes. So since we have defined the domestic installation, we can now focus on the standard values. Okay, so in South Africa we have standard values of the frequency, the voltage, and many more. So we'll just start with the voltage. The standard value of the voltage in South Africa is 230 volts, and the frequency is 50 hertz. These are the standard values in South Africa. They never change. Those are the requirements. Okay, so we go to the South African national standards. Okay, what is the South African national standards and what is their aim? Okay, so the South African national standards, it's an organization that sits and discuss on how things should be and check on the quality of things. Okay, this South African national standards ensure that people are protected, appliances and property from electrical hazards. Okay, the South African national standards ensure wiring in homes follow safety rules. Okay, they are there to ensure, it's a set of rules to ensure that the wiring in homes follow safe rules, guys. Okay, so I'm just gonna write the purpose, not the purpose, the aim of the South African national standards. Number one, to ensure safety. One can say they ensure quality electrical installations. quality installation. Yes, and they protect sorry about that. Protect. They protect property from electrical hazards. Okay, then we can move on now. Okay, now we have to look at sorry. We have to look at conditions when electrical installation must activate protection devices. Okay, these protection devices must activate when sorry yes, in electricity we have a protection devices in which they help us which they help us not to experience earth faults, short circuiting, and overcurrent. So these conditions occur, they activate when there is overcurrent, they occur when there is earth and then when there is a short circuit. Okay, what do we mean when we say a short circuit? A short circuit is not an electrical circuit enough. No, guys, I used to think that also, but then a short circuit is when there's a fault in electricity actually, whereby it's either your appliances are damaged or are wet. Short circuiting also, it comes from a live wire when touching a neutral or touches an earth. You see, that will cause the circuit to break. It will cause a short circuit. Okay, an example: a kettle drawing too much current will trip the circuit breaker, so there will be an overcurrent. The kettle will short circuit. I don't know if we understand each other, but we'll get to questions. You will get to understand me much more better. Okay, then now we move on. We have safety principles. We have safety principles. Let me just use the yellow one for once. We have safety principles that we have to follow in order to be safe. Okay, an example: a socket cover protects you from touching a live terminal. So which this one tells us that a live, if you can remember from basic principles of electricity, I on my first video I stated that I answered the question whereby A learner asked me, why do birds don't get electrocuted? So that simply explains that a copper wire is covered with a plastic insulator. So the birds can rest on it without being electrocuted. So this same applies to a live wire. It must be covered or insulated or made inaccessible so that we must not get electrocuted. We must not get an electrical shock. So live wires must be covered. Okay, and temperature is another safety principle. So the temperature must not be high. Okay, it must not be high while operating. So when the temperature rises while operating, it can cause the generator or transformer to overheat, and it will cause damage. It can bring fire hazards and everything. So if the temperature does not be too hot while operating, it will prevent fire hazards from happening. So the temperature must not be high. Yes, there's that. Then we have a distribution board. The distribution board, some call it a circuit breaker. I don't know why, but there is a distribution board which the distribution board is a panel that distributes electricity to different circuits in a building and houses, protecting devices such as NCPS, earth leakages units, and bus bars. Okay, so where the distribution box may not be mounted, so the distribution box must not be put in. Let me just. The distribution box must not be put in a wet area. Because imagine water getting into the distribution box, touching live wires there. It will be a disaster waiting to happen. Yeah, it will shock the hell out of someone and can bring a dangerous fire. So you must also not put it in a bathroom. Okay, you must not put it behind a locked door. So these are the places where you must not put sorry, where you must not put your distribution box. Okay, then we have a bus bar. A bus bar is thick when the current is high. Okay, so let me just use the green one for now. Thick bus bar equals to high current. So that's how you know things. Okay, miniature circuit breakers. Miniature circuit breakers protects the circuit from overheating, overcurrent, short circuits, and it automatically switched off the circuit. So normally when something trips, somehow the electricity just goes out, but then on your distribution box and your meter box there's still electricity. When you try raising it up, it falls again. So that's a miniature circuit breaker. It automatically switches off when there is a disturbance. It's either overcurrent or short circuits. It will automatically shut down the whole system. Okay, so that you must also know. Then we have an earth leakage device. Okay, we have an earth leakage device. Let me just draw this one, take note. Let me just change colors here. We have an earth leakage device. Okay, an earth leakage device, it protects people from electrical shock. It protects people from electric shock. It detects leakage current to earth. It disconnects the supply quickly when faults occurs. Okay, those are the three functions. Can be more, there are actually more than that. So you can decide whether to put 1, 2, 3, 4, 5. It's up to you guys. An example of an earth fault at home is a damaged kettle where the live wire touches the metal casing. And then there are another one, let me think. Oh, the current flowing to the earth. So that's another an earth fault. So earthing, what is earthing? Because I'm talking about earthing. Earthing occurs when there's a connection of an exposed metal part of an electrical equipment to the ground for safety. You must earth for safety to prevent electrical shock, to provide a safe path for fault current. So these things are not basic knowledge. You must know them. You must listen attentively, because some things I'm not writing, but then they are very important. So we also have an earth spike, a metal rod driven into the ground to improve grounding connection. Okay, that's how things I put it. So now let's go and attempt the answers. Let's go and see now. Define the term domestic installation. Remember, I told you that the first thing you must know about this topic is how to define the term domestic installation. Okay, so I said, okay, let me just do this. You can pause the video and try the questions by yourself. Where you are stuck, I'll continue the video and you will get to see where you are stuck and participate. You see? So now we can start defining. Okay. Yes, now we define. Okay. A domestic installation is the complete electrical wiring system. Inside a home. That supplies power to the appliances. So that's the basic definition of a domestic installation. Okay, remember I told you about South Africa having the standard values. Okay, I started with standard value of the voltage, which is 230 volts, 230 volts AC, which means alternating current. Okay, then we have the frequency, which is 50 hertz. Frequency of South Africa is standard to 50 hertz. Sorry. Oh. sorry about that. So use 7.3. They say draw a block diagram, show the sequence of electrical connection from the supplier to the consumer. Label the diagram. This question I like it now because it explains the whole operation system of electricity. Okay, so now we have to put it in simple terms because we can do the house, like the house system, and also we can do the South African national system. So in South Africa, okay, let me just fix my pens here. In South Africa, we have a power station. I'm just gonna draw. Why is it my okay? Draw it with the black. In South Africa, we have a power station. We have a power station, and then it generates electricity. Electricity is generated in the power station. Then the electricity is transferred to the substations. At the substations, they boost electricity and distribute it to houses. And from the houses to the distribution board inside the house, then to the plugs. That's to the plugs or to the circuit. That's how you should draw it. Okay, so here it's a power station. It's a power station. We have transmission lines. And then we also have the distribution board. I'll just say DB. You guys write it in full. Then we have we have a meter box here. It's an MB. Just write MB, not a DB. Here is the DB. The DB, the distribution board. Then there is a circuit. Which means it goes to the plugs. Okay, it goes to the plugs inside the house. So that's 7.3. Now we look at 7.4. What does SANS stands for? Okay, SANS stands for South African National Standards. Remember, I spoke about South African National Standards during our lesson now. So SANS stands for South African National Standards. Let me just move my mouse, my screen to the side. Okay, National Standards. Okay, describe their aims. Okay, yeah, their aims. Remember, we spoke about aims. So their aims, they ensure safety, I spoke about these things in the lesson. Remember, there are some things I didn't write them down, but I explained them. I explained briefly. Even if I didn't explain briefly, I said during the questions, you will understand them much more better. So they ensure safety, they ensure quality connections. Connections. To protect people and property from electrical hazards. Okay. So they protect and we can just say the environment from electrical hazards. Electrical sorry electrical hazards. Okay, so those are their aims. Okay, then we go to, let me just, okay, when we go to 7.6, two conditions, states two conditions which electrical installation must activate protection to protect devices. Okay, conditions. Okay, the conditions I explained there. I think I explained this one. If I didn't, please forgive me. There are two conditions. Let me just zoom in. The two conditions are when overcurrent is taking place. I'll just say overcurrent. Occurring. And short circuit or earth falls occurs. Let's just say short circuit occurs. So when a short circuit occurs, the electrical installation must activate the protection to protect devices, which means it will trip the circuit breaker so that the whole circuit automatically switches off. That's what they mean about activate protection to protect devices. So that's what actually happens. Hence, I explained with a kettle that if it draws too much current, it will trip the current, it will trip the circuit breaker, sorry. Okay, then 7.7 safety principles are important in electrical installations. Describe the principles must be adhered to with reference of being to follow the to the following, sorry, with reference to the following. Live parts, I said in the first recording that live wires must be insulated, so must be insulated to protect us from electrical shock. They must be covered or hidden by making them inaccessible. By making them inaccessible so that we must not get shocked. Okay, the temperature must not be high. Okay, the temperature must not be high so that there cannot be fire hazards. That will be your reasoning. It must not be high, which means the devices must not become too hot during operation. Okay, sorry, let me just rub here. Okay, 7.8. Oh, sorry about that. 7.8. Answer the following questions with reference to a distribution board. Okay. Number 7.8.1. Define the term distribution board. Okay. I defined it, but then I remember I didn't write it. Okay, here, let me write it here now. Okay, I would say distribution board is a panel that distributes electricity. It distributes electricity. Let me increase here, sorry. That distributes electricity to different circuits. In buildings. Okay, the houses. Okay, and houses. protective devices. Okay, that's a simplest definition of the distribution box. The DB, it's a panel that distributes electricity to different circuits in buildings and houses. Protective devices. Okay, so name one place where the distribution may not be molted. I named one place which you cannot put the distribution box, okay, in a wet area. Some can say in a bathroom, it's also fine. It's also fine. And some can say behind a locked door, it's also fine. Remember, I gave you three, so you can choose anyone, and there are more than that. You can't put them in the sun also. You can also write that. So now let's go to 7.8.3. Describe how the size of a booster is determined in a distribution board. Remember I said if you see a thick booster, a bus bar, sorry, why am I saying booster? A bus bar, a thick bus bar, that means the current is very high. So how do we determine the size? With the current value. So if the current is high, the bus bar will be thick. So here is a simple answer to that. Describe, okay, answer the following questions. Describe the functions of a miniature circuit breaker. The function, it protects a circuit from overcurrent and short circuits by automatically switching off the circuit. You can just write it like that. It doesn't change. It's like that. A miniature circuit breaker. It protects okay. It protects. Okay, sorry, where was I? It protects a circuit from overcurrent. And short circuits. Okay. Sorry about that. I got lost in a moment. It protects a circuit from overcurrent, short circuit, and okay by switching off the circuit. So while it does that, I told you, like when there's a fault in electricity, when electricity trips, there will be overcurrent and short circuits. So the circuit breaker, it automatically switches off the plugs in the circuit. It switches off the circuit. It trips the main switch. So once the main switch is off, there won't be any electrical activity. So that's the function of a circuit breaker. Okay. Okay, sorry about that. Yes, now we are at 9.7.9.2. They say describe the operation of the electromagnetic miniature circuit. Okay, now you'll see. Okay, when the current becomes too high, okay, when the current becomes too high, the magnetic coil produces a strong magnetic force. Okay, this force pulls the pivot arm, opening the contact. The spring helps disconnect the live conductor. This stops power from protecting the circuit. Okay, they say this force, okay, the current into the household or business, it is flowing from, okay, let me just put it, it's flowing from the circuit breaker to the household. Here it is. Okay, then they say the magnetic coil produces a strong magnetic force. Here it is. So this force pulls the pivot arm. Here is the pivot arm. It pulls it, meaning it takes it up, opening the contact, opening here. The spring helps disconnect the live conductor. So this one is a conductor here. So the spring helps disconnect the live conductor. Here's a live wire, and it flows to the coil. From the coil, conducts it conducts electricity with the pivot arm in contact with the conductor. Also here it's a contact. Okay, so once the spring helps disconnect the live contactor, the whole contact will stop, so there won't be any current flowing into the household. I hope you understand me, because I feel like I didn't explain that well. Okay, let me try again. This is a coil. Okay, it's a magnetic coil which produces a strong current because of a strong magnetic force because of a high current. Okay, this force pulls the pivot arm. It pulls this to create an opening from the contact. Here's the contact here. Again, I circled, which means there won't be any power flowing and protects the circuit. So there won't be any power current flowing to the household. I think I'm clear now. So we continue. They say give the current rating of a miniature circuit breaker used to protect a lightning circuit. Give the current rating. it's actually 10 amperes. I didn't mention this, guys, sorry. It's 10 amperes. Yes, it's 10 amperes. So going back to this, let me just rub here. Going back to the circuit and explaining it perfectly fine now. The contacts that keep the circuit closed are held by a latch. Okay, these are the contacts. Okay, then it's stated that sorry sorry about that. The magnetic field setup in the structure will be very strong enough to pull and release the latch due to the high current. Here is the magnetic field. Okay, this open the contacts and disconnects the current flowing through the circuit breaker. Okay, so it will be strong enough to pull this pivot. I mean, to make the pivot pull, disconnect the current and the contacts. Okay, let me just put it in simple terms, guys. Sorry. This a magnetic coil produces a strong magnetic force which will force the pivot arm opening the contact to disconnect the live conductor. And once the live conductor is disconnected, there won't be any current flow through the circuit breaker. So this one will then close the contact again, so then there won't be any power. So moving on, and describe the two methods used to rate miniature circuit breakers. Okay, from here it's very simple and straightforward. The overload current will open. Let me the overload current will open. The overload current will open under overload conditions. So while it is open under overload conditions, this fault a current that must be able to contain safety and under fault conditions. Do you understand me? Let me explain again. This overload current will open under overload conditions, which will result in the fault current must be able to contain safely under fault conditions. Okay, so I'm just gonna write it here. Fault current must be able to safely contain under fault conditions. Okay, and they say state three functions of a leakage device. Three functions of a leakage device. Okay, let me just put my screen properly. Sorry. Three functions of a earth leakage device. I didn't share them. I'm not sure, but I think I said something about them. But let me just give them. Opens under overload conditions. Overload conditions. Number two, opens under earth fault conditions. Under fault okay. Number three, opens and closes under normal conditions. Under normal conditions. Okay. Answer. Okay, give one practical example of an earth fault that may occur in a domestic installation. Okay, a practical example. Let me think. I would say a fault may occur with a toaster if the installation is one of the live or natural. Okay, and they may come into contact with a conducting part of the toaster. This will create an earth fault. Okay, even if with that kettle, I remember making an example with a kettle. Yes, with a kettle. So it's nothing major. I'd say in a kettle. Let's do an example of a kettle. Sorry, let me just yeah, sorry, yeah. I'll write the answers here. Let's say a damaged kettle where the live wire touches the metal casing. The current flows to earth and earth leakage device trips. Okay, I hope you understand that. Just struggling to write here. I think here's my mouse. Here's my pen. The current flows to the earth. Oops, to the earth then the earth, the church, device, verbs. Okay, let's go to another question here. 7.11. They say define the term earthing. Define the term earthing. So I'm just gonna zoom in here. 7. Let me change pens. 7.11.1. So to define the term earthing, so earthing connects exposed metal parts of electrical equipment to the ground for safety. Okay. Is there any other way I can put this? Let's just write it the way it is. Earthing connects exposed metal parts of electrical equipment to the ground for safety. Okay. What is the purpose of earthing? Okay, the purpose of earthing. Number 1, I told you that it is to prevent electrical shock. And another one, I said it provides a safe path for a fault current. So yeah, how many do they want? They just want 1. Sorry, I'm not well today, guys. So the purpose of earthing, 7.11.2, to prevent electrical shock. Okay. Eleven point 7.11.3 describe the type of resistive value an earthing system should have. Okay. See what describe. Okay, this one is just so easy. 7.11.3 a resistive an earthing system must have a low resistance. In the event of an earthfall, the current will take path of least resistance and discharge down to earth. Okay, so it's straightforward, this one. They said describe, so we mustn't explain. Let me see. Describe. Yeah, we mustn't explain, just have to describe. So it should have a low resistance to allow easy flow sorry I did a mistake. Just easy flow of just easy flow of fault current and then the F spike, okay, that's the next question. Let me just go there now. I forgot that you guys can't see my screen here. Explain the term F spike. Okay, these things are simple, yo. 7.11.4. An F spike, a metal rod. An F spike, a spike, it refers into something that is in the ground. So once you hear spike, it's something that's inside something or inside the ground, okay? So an F spike, it's a rod driven into the ground to improve grounding connection. Yeah, so in simple terms, you just put it the way it is. Okay, here's an example. Sorry. Is an example of an earth spike. So if you can see those light poles, they are spiked into the earth for better ground connection. So if you can see, you can't see a naked pole like hanging alone. It's either it's in the ground or being held by two wires on the sides. So that's an earth spike. So a metal rod driven into the ground to improve grounding connection. So that's how it is. That's how it should be. I hope you have a blessed day and a blessed night. Amen. Goodbye, guys. This is the end of our lesson. Ciao.